Dicarboxylic acids. Dicarboxylic acids are compounds that contain two carboxylic acids. Here are some examples for dicarboxylic acids. Oxalic acid is an example for a dicarboxylic acid where the two carboxylic acid groups are separated by 0 carbons. You do not have any carbons in between. Malonic acid has 1 carbon in between. So basically this is going to be a CH2 group. And succinic acid has 2 CH2s in between the two carboxylic acids. Although the two carboxylic acid groups are identical, they are not going to have the same pKa values because the protons are going to be lost one at a time. For example, let's consider this molecule. When you want to remove the first hydrogen, it needs to come out from a neutral molecule. Now also, you do have a carboxylic acid which is electron withdrawing. So which is going to make this compound more acidic, and that's why you have this pKa value to be 2.86. But when you want to remove the second proton, it needs to come from a negatively charged species, right? It will be relatively hard for this negatively charged species to lose another proton to form this di-negative ion. And that is the reason why you have a higher pKa value here. When you take a look into the pKa values of these different dicarboxylic acids, you can see that it is gradually increasing, which means this is going to be a strong acid. And this one right here is a weak acid. This can be related to the number of carbons that's separating the two carboxylic acids. As you increase the number of carbons between the two carboxylic acids, you can see the effect of the carboxylic acid has been greatly reduced, and this proton cannot be easily lost, and therefore this is going to be the one which is a weak acid. Dicarboxylic acids, when they are heated, they readily lose water molecule to give us the corresponding anhydride. This is glutaric acid, where the two carboxylic acid groups are separated by 3 carbons. And when you heat this, this molecule is going to undergo dehydration to give us the corresponding anhydride, glutaric anhydride. This is phthalic acid. When you have two carboxylic acid in the adjacent positions of the benzene ring, then it is called as phthalic acid. And this also undergoes dehydration to give the corresponding anhydride, which is called as the phthalic anhydride, the cyclic anhydride. We can also obtain the cyclic anhydrides by reacting the dicarboxylic acid with either acetyl chloride or acetic anhydride. So for this reaction, you will also get two equivalents of the carboxylic acid.